I hope you all are fine and safe at your home. So today we are going to start a new chapter, chapter number 2 of physics. The name of the chapter is Force and Laws of Motion. In the previous chapter we had already learned about motion, but in this chapter we will learn about the cause of motion. In the previous chapter we only learned about the different types of motion and motion. In this chapter we have to learn about the cause. What is the cause behind that motion? I mean to say we will learn about force. So let us take the introduction of force. Actually, in our daily life, the force is applied in everything. There is no any object which is independent of force. For example, if we want to open the door, we push it or pull it. If we want to lift something, we apply force. If we want to put a nail into a wood, we apply force by hammer. There are a lot of examples of force in our daily life. Without force, it is impossible to do anything. So, I have given you examples. For example, for opening the door, we need to push or pull. If you have seen in remote areas, people fetch water from the well. They apply force on the pulley so that they can uplift the water. This is also an example of force. Nail I have given example. Now let us write the definition of force. What is the definition of force? Technically, force can be defined as it is the external effort in the form of pull or push which is required to change the state of a body. Now a new term has come, state of body. As we have already discussed, there can be only two states of body, whether it can be in rest or it can be in motion. So to change the state of body means to make a body from rest to motion or from motion to rest, we need to apply force. Force is very important factor to change the state of body. Suppose a football is lying in a field. It is in rest. Suppose we want to make it in a motion, then we will kick it. Means we are applying force. Another example, suppose a football is moving. Suppose we want to stop it. Means from motion to rest. Then also we will have to apply force. From these two examples, we conclude that to change the state of a body, we need to apply force. Without force, the state of the body cannot be changed. Okay? Then we have defined force. Again, I am repeating the definition. Force is the external effort in the form of pull or push that is required to change the state of a body from rest to motion, from motion to rest. Okay? An example you can give. There are a lot of examples. I have given 3. Now, after this topic, a very important topic is balanced and unbalanced force. You can see that these are two types of forces. There are many types of forces, but these are important type of forces. So let us understand this by an example. Then after that we will define it. First by example. Balanced. As the word looks, balanced means equal. Unbalanced means normally unequal. So suppose there is a box which is lying on a table. There is a box which is lying on a table. Two forces are applied on it. Suppose two persons are there. This is a string. This is a string. It is attached to the box. Suppose one person is applying force of 10 Newton in this direction. Suppose another person is applying a force of 10 Newton in this direction, means opposite direction. These two forces are equal. 10 Newton are equal. But what is the difference? They are in opposite direction. Suppose this is north direction, then this is south direction. This is example of balanced force. I hope you might have understood by the example only. What is the definition? In the definition we can write balanced force are those forces which are equal in magnitude but opposite in direction. Magnitude means amount, how much force is there. Again I am repeating it. Balanced force can be defined as those forces which are equal in magnitude but just opposite in direction. This is a very good example of balanced force. Now let us see an example of unbalanced force. One more point I would like to tell you, you have to note it. In balanced force, net force equal to 0. Okay, we will study in the next chapter or further what is net force. But currently you note only net force is equal to 0 in balanced force, and net force is not equal to 0 in unbalanced force. You have to only note it down. You will study further in detail about this. For example, take the same experiment. Take the same experiment. A box is there lying on the table, but the difference is that force are applied in different magnitude. Now, in the south direction, 50 Newton force is applied. Some person is sitting and a string is attached to it. He is pulling by a force of 50 Newton. Suppose another person is pulling from that side of 20 Newton. If I ask you in which direction the box will move, it is common, it is but natural. The box will start moving in this direction, because in this direction the overall force is more than this force. Means net force equal to 50 minus 20 equal to 30. 30 Newton is acting in this direction. 20, this 20 is cancelling 20 inside it. 30 is left. 30 Newton is acting in this direction. Therefore, net force is called 30 Newton in this. This is an example of unbalanced force. Achha, one thing you will see here, if you see carefully, in this the box is not moving, although two forces are acting. Although forces are acting here, but the state of the body is not changed. Previously also this box was at rest. After applying force, then also the box is at rest. Then what can we conclude? We can conclude that in balanced force, the state of the body remains same. And in this, the body was at rest initially. But after applying unbalanced force, the box will start moving in the direction of the greater force. So I hope you all are getting my point and you have understood it. What are balanced force? What are unbalanced force? In our daily life, both these forces come into observation. Okay? Now let us see what are the characteristics of forces or force. Characteristic means effect. What can it do? What are the phenomena regarding it? What are the characteristics? Or you can say what are the function of a force. In any way you can say all the meanings are same. Means the first effect of a force is to change the shape. I would like to give an example. Suppose there is a balloon. It has a fixed shape. Suppose if we press or apply force on the balloon, the shape of the balloon will change. Okay? Another very good example is there. Suppose there is a toothpaste. If you want to take out toothpaste, you have to apply force on the toothpaste, and you will observe that the shape of the toothpaste is changing. Both are the effect or the function of the force. Means force is responsible for that change in the shape. Without force, we cannot change. So this is the first function or effect or characteristic. Okay. Let us now see the second characteristic, which we have already discussed in this example. The force can change a body from rest to motion. For example, I am giving example of this sketch marker. Suppose this is lying at rest on my hand. It will not move by its own unless I apply some force. For example, see, I am applying some force here. It has changed from rest to motion. Again I am applying force, it is changing from rest to motion. So we can say that to make a body change from rest to motion, force is necessary. Okay. Another example, suppose there is a table at your room, in your room. You want to shift that table into another room, then you need to push it or lift it. Anyway, you have to apply force in order to change the state of the table which was in rest to change it into a state of motion. Okay? Many times in your home, you shift chairs from here to there. You apply force so that the chair can move. Okay? Okay, let us see the another aspect or characteristic of force. It is opposite to the second one, from motion to rest. From motion to rest. Okay? A very good example is there. You might have seen a lot of football matches. There is a goalkeeper. The main target of the goalkeeper is to catch the moving ball, football, and make it into rest in his hand, so that to avoid goal. Suppose football is moving, he hold it, he catches it and make it in rest. The football was moving, now it is lying in his hand in rest position. It is an example of characteristic from motion to rest. I hope you are all understanding. These are simple points. You might have read it in 8th class also. This is just a type of introduction. The main concept is going to start from this or after this. This is a basic concept, you can say, of these chapters. Now the final effect of force is change direction. Change direction. For example, say, suppose a ball is rolling on the ground in a straight path. A football is rolling on the ground in a straight path. If we want to, now the direction of the motion of the ball is in this direction. Suppose I want to make this ball move into this direction. Can it move by its own? No, not possible. We have to apply force here. Suppose it has come here, there is a player here. He will kick this ball, apply force in this direction. Suppose this is west, this is south. From this example, we note that to change the direction of a moving body, a force is required in that condition also. It cannot happen automatically. Okay? Okay. Then, now let us come to the next topic, inertia. Inertia. This is a very new topic for you. As I have said in the earlier chapter, the topic which is coming for the first time, it should be focused more. It should be discussed in more detail. The topics which are older. So let us understand about inertia by an example. As I always keep saying that to understand any topic in physics, if you understand it from an example first, then it will become easy for you. To understand any topic, we have to relate that topic to the practical phenomena. So, let me try to relate this inertia by an example. Suppose there is a stone in a field. It is at rest. It will not change its position unless and until some external force will be applied. Suppose no one is disturbing it. Means no one is applying any force for several days. Then after 1 month also, the stone will be lying at that position only. After 1 year also, if someone is not disturbing it, the stone will lie at that position only. After 10 years also, if no one has disturbed it, disturb means no one has applied some force on it, it will lie at that position only. From this example, we summarize, we conclude, or we understand that to change the state of the body, force is required. In reverse way, we can say the body is unable means not able to change its state automatically by itself. This is only an inertia. Have you understood? Now let me define it. Inertia is the inability of a body to change its state by itself. Okay? This is inertia. This is known as inertia. It is the property of every matter, of every object to resist the change in itself automatically by itself unless some external force is applied on it. Okay? Have you got it? Okay. Take another example. Suppose a table is lying in your room. Can you think the table can automatically start working? or moving and it changed its position from one room to another room, it's completely impossible. The table cannot change its state by itself automatically. This is only called inertia in physics. Means inertia is a property of an object which resists to change its state. For example, let us take another example. Suppose this is a frictionless surface. There is no friction like this whiteboard. Friction is very less. If you walk over this, you can fall down. Suppose on a frictionless surface, a bicycle is moving. Okay? Then, according to inertia, according to physics, this bicycle will be in motion forever and ever. It will never stop unless and until some external force is applied on it. It will maintain its position. It will maintain its situation. Means it will retain its state of motion. This is inertia. Okay? Let us take another example. Suppose a stone, this is earth. Suppose this is earth. A stone is falling in a straight direction. We all know everything falls in a straight path. This stone is falling in a straight direction. It will remain falling in a straight direction unless and until this stone or any object is applied by some force. For example, this stone is falling and suddenly some strong winds start blowing. Can you think that this stone will remain travel in a straight path? No. This force by wind will change its direction. It may come like this. From here we can say that this is called inertia of direction. Means the stone was trying to move in a straight direction, but the external force has forced it to change the direction. If this external force was not there, this stone would have moved in a straight path. This is called inertia. Means from these three examples we can say that inertia are of three types: inertia of rest, inertia of motion, inertia of direction. Okay, so let us now start a new topic, momentum. This is really very important term, momentum. Let us define it. Here I have written the definition. The product of mass and velocity is known as momentum. Suppose some body is moving, it is in motion, it has some mass. Then if we multiply its mass with the velocity, then we can get the momentum of that body at that incident. Let me explain by an example. Suppose a body has mass 10 kg. Suppose an object has mass of 10 kg. It is moving with a velocity of 2 meter per second. 2 meter per second. Then suppose it is asked to calculate the momentum of that body. Then what we need to do? We need to multiply the mass and the velocity. Then momentum equal to the momentum. The symbol of momentum is P. It is denoted by P. P means it is the symbol of momentum. It is a denotation of momentum. Then in this case, what is the momentum? Mass into velocity. Then what is the mass? Mass is 10 kg. 10. What is the velocity? 2. Then what is the momentum? Final momentum is 20 kg. So the momentum is 20 kg meter per second. This is the unit of momentum. What is the unit of momentum? Kg meter per second. Okay? This is very important point to note. It sometimes comes, you write the unit of momentum, then you have to remember it. Kg meter per second. Okay? Now, let us move forward to the new topic, which is very important. Newton's law of motion. As you all know, the great scientist Newton researched a lot about motion. During his practical observation and research, he gave three important law of motion regarding motion. Okay, so let us, as you all know, in nature every phenomena has some rule and principle. Every phenomena, every process follows some rules and principles. Likewise, this motion also follows some basic principles and laws. That laws is studied in these three laws of motion. So let us study first law of motion, Newton's first law of motion. Let us first read or see the definition. What the definition is saying? The definition is saying a body at rest will remain at rest, and a body in uniform motion will remain in uniform motion unless and until some external force is applied on it. Don't you think it is looking similar to the inertia concept? Inertia also said that the body at rest will remain at rest, the body at motion will remain in motion unless some external force is applied on it. Likewise, it is the same, it is denoting or saying the first law of motion. That's why sometimes this first law of motion is also known as law of inertia, because it is directly pointing to the concept of inertia. What the inertia concept is, the same concept is of first law of motion. Then if you already know inertia, it will be very much easy for you to understand this. Let me now explain this. We have read the definition. Let me explain this by an example. This first law of motion says that if the body is at rest or if the body is in uniform motion, it will remain in the same state unless an external force is applied on it. Okay, understood? Okay. Now let us move forward to the second law of motion. This law of motion is very much important because it gives mathematical definition of force. It gives mathematical definition of force. The first law of motion gives the theoretical definition of force, and the second law of motion gives mathematical concept of force, how to calculate force. From the first definition, we come to know what force is. Force is an external factor, external influence, external strength, which cause to change the state of a body. But from the second law of motion, we come to know what is the mathematical formula, what is the mathematical expression to calculate the magnitude of force. So let us see what is first. See the statement. The statement says the rate of change of momentum is directly proportional to the applied force. Okay? Have you seen it? Now let me explain by an example, because you might have not understood by this statement. Let me repeat it. According to the second law of motion, the rate of change of momentum is directly proportional to the applied force. What it means? Let me give you an example. Suppose a body of mass 2 kg. Suppose a body is there which mass is 2 kg and it is moving with 1 meter per second. 1 meter per second. Then what is the momentum? Momentum equal to 2 kg meter per second. Suppose after 1 second, the speed is 2. The speed has increased. For example, after 1 second, this 2 kg is moving with 2 meter per second. Then at this position, at this situation, what is the momentum? It is 4 kg meter per second. We have seen the moment here, the momentum is 2 kg meter per second. After 1 second, how much? 4 kg meter per second. From this example, we see that momentum is changed when the velocity is changed. See, the velocity is 1 meter per second here. the velocity is 2 meter per second here. In these two situations, the momentum is different. This is called change in momentum. Change in momentum. The second law talks about the rate of change of momentum. Means how much momentum is changed in 1 second. How much momentum is changed in 1 second here? 4 minus 2 equal to 2. 2. Right? 4 minus 2 in 1 second. The 2, we can say in this situation the rate of change of momentum is 2 kg meter per second. Okay? This is talking about this. We can understand it in other way. It says that if we want to double the rate of change of momentum, we have to double the force. We have to increase the force by 2 times. Means if we want to increase the momentum by 2 times, then we have to increase the amount of force by 2 times. If we want to increase the momentum by 5 times, then according to this law, we have to increase the magnitude of the force by 5 times. This is the meaning of directly proportional. What directly proportional means? Directly proportional means two quantities are increasing by the same times, same multiple of times. Okay? Then I hope you have understood the second law of motion. After this topic, we will learn the derivation of the mathematical formula of force. Means in the next topic, we are going to study the derivation of what is the formula of force. Okay. Now let us study about the mathematical formulation of second law of motion. In this topic, we will derive what is the how to calculate the numerical value of force. What is the mathematical formula? So let us start deriving it. Suppose a body of mass m is there. The initial velocity is u. The final velocity of that object is v, and the time taken is t. It is taking t time from u to v. Then what is the initial momentum? Means the starting momentum, mass into initial velocity. What is the final momentum? Mass into final velocity. Then what is the change in momentum? The momentum is increasing, changing, or you can say decreasing or increasing. It is changing. Then to calculate the change in momentum, we have to subtract. We have to find the difference between the final momentum and initial momentum. Then what is the final momentum? mv minus what is the initial momentum? mu. Then how to find the rate of change of momentum? To find the rate, we have to divide by time. Rate is in terms of time. Rate means per unit time how much it is changing. Then to calculate the rate of change of momentum, we have to divide the change of momentum upon time. Then we have done this. We can rearrange, simplify it. M is common. I have taken M as common. Then what will be inside the bracket? V minus u. Then this has come. Remember this point. This is very important. M v minus u upon t. Then according to second law, what it says, force is directly proportional to the rate of change of momentum, and we have already found the rate of change of momentum. Then we have to place here. Then I have placed this value in the definition. Then we can write F is directly proportional to M into V minus U upon T. From the previous chapter, if you remember, what is this quantity V minus U upon T? This is nothing but the acceleration. What was the formula for acceleration? V minus U upon T. Then instead of this V minus U upon T, we can write A, acceleration. Then it is reduced to F is directly proportional to mass into acceleration. We can write F equal to K into M into acceleration. K is called proportionality constant. It is called constant of proportionality, K. Then if we put the value of K equal to 1, we can get the formula F equal to mass into acceleration. This is the mathematical expression of force. This formula is used to calculate the amount of force. So this topic was very important. It shows how the formula of force came, force into acceleration. So for this lecture, this is the last topic. The next topic will be I will teach in the next lecture. Up till here, please revise all these practice questions and all that. I hope you all understood it. Okay, I would like to end here. Thank you.